Okay, thank you for answering those questions. So now we will change from steel industrial sector to the pulp and paper sector with results from the SPOTVIEW project. So the first presentation will be from VTT, Mr. Antti Grönroos. He prepared this presentation with Essity Valmet. So this presentation will be about new strategies and innovative technologies for process water recycling in tissue paper industry. So Antti, if you can hear me, it's your turn.
Yes, thank you a lot, Eric, for these nice words. And as you can see, the topic is quite high, or quite big one. So new strategies and technologies for process water recycling in tissue paper industry. And like was already told in keynotes by Jour1 that pulp and paper industry is some kind of leader in this kind of water reuse and water recycling issues. And maybe it's difficult to find new things and new possibilities to water savings and such kind of things. But let's see what we did and how we succeeded. So about the outline of my presentation first, what was the objectives of the work, and then about background of our case mill, Essity Nokia tissue mill here in Finland, and then how we did it and how we succeeded, and then some conclusions. But first, what was the objective? So we want to save or recycle or minimize the fresh water intake to the tissue mill. And we did it, or we made some kind of new sustainable process water strategies for our case mill. And we did it by modeling and simulation and by kidney technologies. So we used in this case ultrafiltration for water purification, so process water purification by ultrafiltration and back to the process. And at the very early stage, or at first, we make a model of the mill and how where fresh water is taken in mill and where to out, and then this kind of cases how to handle the total process water circulation in general. And in our case, the case mill was Essity Nokia mill here in Finland. Make or what is the platform or products? So some tissue paper, baby diapers, feminine care, orthopedics, and wound care. And Essity mill is quite old mill, so different kind of sectors or sections of processes are quite far away. So they have the inking plant, so they take old paper or used paper back to the process and make some de-inking properties for that, and then they have 2 paper machines, and then they have own wastewater treatment plant. But because that is quite old mill, those all sectors are quite far away, and that's why this kind of reuse or recycling of water is not so easy like in the very new mills. Essity mills in Nokia, they used approximately 2.4 million cubic meters fresh water per year. And if you calculate that in working hours or running hours, it's about 380 cubic meters per hour. And they want to decrease their total freshwater consumption, and they had some new plans for how to make the process better inside the inking plant and also in paper machines, and that we were modeling and simulation during this process, and then we used this kind of kidney technology. Ultrafiltration for water purification, and the total goal for the total freshwater consumption decrease was 30%. And of course, when you are closing your water circulations and you are taking less fresh water inside the mill, there is also this kind of total suspended solid levels and CUDL, so the organic matter levels, they they try to increase because of the freshwater decrease. And that is also what we have to take care of when we are closing our water loops. So reduce freshwater consumption, and we did here 4 different cases, the reference case, and then 3 different cases using this kind of steady state modeling program named by or owned by VTT and named by Balas. And the cases are shown in this slide. So reference case was as the mill was until the end of 2017, no any kind of process water reducing changes were made. And then Essity Nokia did some new things in water circuits inside the inking plant and paper machines. That was case 1. And then case 2 was that we installed one Valmet ultrafilter unit to paper machine 7 to take care of high pressure shower water to the wire section of paper machine when they are making paper. And the case 3 one was the potential future setups, so that we have this kind of ultrafilters, sorry about my English, in PM7 and one in PM9. So those were the cases what we simulated or taking care. And then what happened? The kidney technology, what we used, as I said, was ultrafiltration, Valmet own Finnish company Valmet, and technology owned by Valmet. And by this kind of filtering, we can recycle or we can purify water back to the process. That is the idea of these kind of systems. And we can reduce freshwater consumption, and then together, because we are purification the water, we can improve machine runnability, so not so much breaks used when they are making paper or tissue paper in this case, and then of course efficiency can go much higher because of this kind of systems. Okay. So I think some kind of roadmap of Valmet ultrafilter for tissue machines was this kind of things, that we were or guys from Valmet first made some kind of lab scale filtration for membrane to get the best possible membrane for the purification, and of course the water selection inside the process. So what kind of water they can purify back to the process. And there was building, testing, construction, updating, installation, and such kind of things. And now the prototype has been in Essity mill 18 months, and it has produced 1,100 cubic meters water, so 100 million liters of water inside the mill. So very much during those 18 months. And so here you can see the flux of the ultrafiltration unit. So we use 2 different intake waters to the ultrafiltration. So disk filter, clear filtrate, and cloudy filtrate. And as you can see, we can produce by that one unit about up to 12 cubic meters fresh water per hour. And because the paper machine 7 needs 8 cubic meters per hour fresh water, we can purify, or we can use this kind of machine to take care of whole high pressure showers needs for that one paper machine 7. And about the whole thing, if you are thinking about freshwater decrease or reuse of water, we reached the goal. So the goal was 30% decrease in freshwater intake, and we got with this system 31. And here you can see all the sectors where the water was saved. But anyway, we reached the goal That's nice. And about the conclusions, we did different kind of sustainable water reuse strategies for tissue and paper mill in mainly in Essity Nokia, so here in Finland. We used modeling and simulation and kidney technologies, and that kidney technologies here is only ultrafiltration by Valmet. And we reached the goal. We got 31% reduction in total freshwater consumption in Essity in our case mill. And we use that Palace steady-state simulation software for process modeling, so these water circulation modeling, and then we put that Valmet ultrafiltration for tissue process equipment or prototype to the Nokia Essity mill and take care of that high pressure sour waters for one paper machine in the plant or at mill site. And these tools, both tools are available for sustainable water reuse strategies in tissue paper mill, but of course in every case of pulp and paper mill where they are good to be have in Europe, but also in whole world. So that was very, I think, very fast overview of our new strategies in tissue mill, but here mainly in Nokia mill, Finland. Thanks a lot.
Thank you. I'm just waiting for Eric to come back to the microphone.
Yeah, my microphone was up. Yeah, thank you, Antti. I think we need some clarification first on the term water consumption and water use. When you're talking about water consumption, I think you are mentioning total water use withdrawal intake in the mill, yes. But the water consumption, maybe as it is defined, is more the water that is not returned to the surface water. So maybe we should talk probably more of water use instead of water consumption.
Yeah, that's right. Yeah, sorry about that.
And there is a question about the water use, specific water use per ton of paper in general in tissue or in the demonstration case.
Yeah, in our case, in our case, because Nokia mill is so old one. In the beginning of project, they used 40, so 40 cubic meter per ton, but we can decrease that to 25 cubic meters per ton. But in very new one, those values can be below 10 cubic meters per ton produced tissue paper. That is general.
Okay, thank you. And another question, can you tell us more about the potential heat recovery that you can, and heat saving that you can have when you reuse water and when you close the circuit? Is this a valuable option?
Yes, of course. It's good question, Eric. Yeah. In general, if we have this kind of middle-sized tissue mill, I think it's produced, or I asked from Pasi Nurminen from Valmet, it produces about 1,080 tons, or about 2,000 ton paper per day, one paper machine. And if you calculate about that if you take this kind of process water, which is already in the right temperature, about 40 degrees, 45 degrees, so Celsius degrees. And in general, if you tap water or some kind of water, practice water, or what you take to the process is about 25 degrees, then you don't have to increase the temperature, let's say 25 degrees. So the heating amount is 25 degrees. Then the savings can be about 200 kilo euros, so 200,000 euros per year about those heating value.
Yeah, so this
quite much.
Yeah, this is very interesting. Like during the previous presentation, the value of water saving was from phosphoric acid saving, and here it's more from the energy that you can save by recycling warm water to the process. So
but also water. Also water. Yes.
Yeah, also water.